Today we'll finish up the key loader and its supporting class, the key creation data. I have been behind in all the things, and so I feel I am not doing any of them particularly well, including this one. One of the things that I've been doing is making a video game using KLEP and the KLEP system. It has been providing me a great proving ground to play with it and to refine some of the systems with real-world considerations, including this one. Something that has already occurred has been me finding /keyloader to be really super useful. It is very effective. Keys and their property definitions are governed by a keyloader. Keyloaders are scriptable objects, meaning that you can have as many keyloaders in the system at a single time. And in the Unity system, making one is as easy as a right click. Keyloaders govern the properties of the keys that it issues. This means that if I want to have a normalized value, something that goes from 0 to 1, I can set a float property, fill out the name of the property, and now all keys issued by that loader will have that property. If I want a key to track a position, select the vector 3 from the drop-down and add in the name to the property. Now all keys that are issued from this key loader will have this property. This is incredibly powerful. We touched on it prior when we talked about the property definition manager, but let's go ahead and we'll take a deeper look. So let's begin. At the very top, we'll see that keyloaders hold a list of properties and a list of key creation data, aka the key template. We will look at that subclass later, but for now, all you need to understand is that these hold the fundamental building blocks of a key. They hold the name, the attraction. We then move on to our onEnable function. And just like last time, when we talked about a scriptable object in the Unity environment, we said that it will fire every time that is selected, loaded, or whenever. Therefore, we have protections in place to not override any custom data that we have modified the loader to use. Our key creation data, or our key templates, will always be initialized. Let's take a look at that. The init KCD, key creation data, we see that it looks at the properties that the key loader governs. It then goes through each of the templates and makes sure that those templates' properties match the key loader's properties. It is another reason why only the name and the attraction of the key are exposed, as every time you select the scriptable object, all the properties for its governed keys will be set to the defaults of the key loader. Backtracking, we see that if the list of properties is null, meaning that we just created the key loader and it has nothing there, or if the properties equals 0, meaning that something happened and the properties are gone, we initialize the loader with its default properties. These can be anything that you want to put in, but in my case, I have a wide selection of things I know that as a game developer, I will use often. These are bools, lists of vectors, transforms, floats, ints, and a date time, just to be wacky. We have two that the KLEP system utilizes. Both of these are bools. One is make unique and the other is in use. Make unique allows for a deep copy of a key when it is issued, and we get to see that happen in the next video when we talk about the key manager. Is in use has mostly been used by our debug scripts to graphically show if a key is being used by a lock to utilize an executable. My code may look different than what's on the GitHub page because I found a better way of doing it, and I'm very bad at updating my GitHub page. The utility function adds property if missing does exactly that. It adds a property with the values passed to it. This makes the code cleaner and more understandable, hopefully. Speaking of improvements, you know how I've been saying you can push different keys to the key loader and it could be set to adjust its properties and list of governed keys automatically? Well, I had to fix that, but now it can happen. Why is this useful? Let's say you have 150 keys that can be generated dynamically, and you don't want to feed all of those keys into the key loader by hand. Well, as a scriptable object, its data persists after you hit the stop button. So you could just write a little script that will only push those keys to a dirty key loader I'm calling them now that because it's funny. Then, to preserve that and make sure that nothing else gets added to it, you could turn off this little bool that dictates whether it's dirty or not, which is currently allow foreign keys. But I'll probably change the name to something else. Something more dirt related. Continuing down the script, we have a public function that adds a key if it does not already exist. This lets you move one key or share a key from keyloader to keyloader. This key will then inherit all properties from the loader and abandon all prior properties. If you want to preserve that, you could implement a mutation system. We already have the start of that with the trait allow foreign keys. And as we've said before, we are able to then push a key and have it add its properties that it carries to the keyloader. Other methods exist, and that's why coding is fun, because it's up to you. Once again, to reiterate, this means that if a new property is introduced to the keyloader, every single key that it issues will have access to this new property across the full system. Create key data and get template by name are the two final functions of this class. Both are used widely across the system. Create key data allows any executable, any system, anything, to call into the keyloader and ask for a key to be made. It will return a key creation data, and it will have the assigned name and attraction along with all properties that the keyloader governs. This lets you make keys that aren't officially governed by the keyloader, something that you only need for, like, say, a frame, and push that to the neuron. Whereas the other function, get template by name, allows you to return a key that is recognized by the keyloader and that had been set up prior. If you know that you'll be using a W key to move an agent forward, then this is what you would call to get that key creation data. It helps with organization, and if you expose some of the properties to be modified in the keyloader, because coding, it's up to you, you can do that. And so this will allow you to then call a template that already has pre-set up data beyond just the name and the attraction value. This could be a series of stats for a character or things of that nature, and then it will return that. Let's continue, because the KCD itself is a very simple class. As stated prior, all keys only need a name and an attraction value. The expected keyloader is included as well for reasons unknown. No, seriously, I totally forgot why it's there. We have our constructor that allows KCD data to be created. And this is what you actually pump data into, the name, the attraction, and the properties to be applied to the KCD. Our generic constructor just makes a new and empty property list, and this is for null protection. Finally, we have our Big Bertha functions set property. First, it checks to see if the property is there. If so, it sets the property. If not, it deals with those edge cases. First, it sees if the expected loader accepts foreign keys. If so, it adds the property to itself, and it should add the property to the property manager. It then determines the type of data the property will utilize, and then sets that property key value. Finally, it adds the property to the property list. Otherwise, it's not a valid key and nothing can be done, so we log an error. This concludes the keyloader and key creation data class. The next video will finally cover the key manager, and we get to go in depth about the key lifecycle in KLEP. Then we get to the fun stuff, such as executables, how executables operate, and what they do. They're the things that actually affect the game world, so, that's neat. Without this groundwork, it's an incomplete understanding of a difficult system. So thank you for sticking with us all this time. And if you want to get in touch, you can follow me on Twitter. I'm active on Twitter now. Yay, Twitter. Email me at rolling44@gmail. And if and only if you want to wait an eon for me to check my email, you can support me on Ko-Fi or not. I haven't really set that up, so it doesn't matter, lol. I got a game that I'm putting hours into, and it uses KLEP, so that should be a thing sooner rather than later. And if you want all of those interesting little GIF updates, just go to my Twitter, and that's where you can see all those. As always, thank you for your time, and thank you for your interest.